Hi there, everyone. We've got just a brief set of notes today. But as we get going, I get this weird question sometimes, because I wear ties a lot, and students are always like, well, how many do you own and where do you keep them all? And so this is my closet. And actually the ties are up on the third floor of the closet, which again, I don't know why you design a closet with 3 floors, but it is what it is. I'm not going to complain too much, but sometimes I'll have to grab a few ties at a time because I don't have to walk up there all the time to get ties. But so anyway, this is where I keep all the ties. So we'll get going, and it's a brief set of notes on something called percent composition. And so pay attention to the definition today and pay attention to I would write down one of the examples that we end up doing. So definition for percent composition is simply it's based on the mass. It's the percent of mass of each element within a compound. You'll see this is directly related, and actually you have to find molar mass first, and then you're allowed to then go and find percent composition. In terms of an equation, here it is. It'll make sense as we practice with it, but to find the percent composition of an element, you'd have to take the mass of that specific element and divide it by the total molar mass of the compound. And because this is a percent, then you would need to make sure that you multiply by 100. So you can pause and write that down, but as just a quick overall example, I'm going to use that calculation above. And the idea is if you have, let's say, 4 elements in your compound, you're going to have to do that calculation 4 times to get the percent for each element. We're going to go ahead and look at lead 4 oxide here. So there's just 2 elements, which means I'll do that calculation above just 2 times. And I've given you the full molar mass here. So the molar mass for the total compound is 239.2. And where does that number come from? Well, remember that lead's going to contribute 207.2, and the 2 oxygen will contribute 32. And remember, we're getting those numbers from the periodic table. And so you'll notice that oxygen with rounding is 16. To multiply that by 2, and we get our 32 grams. And then down here for lead, it's 207.2, and there's just one of them. So that's where the numbers are coming from. So I'm going to kind of show you a quick idea of overall what's happening here for percent composition. We'll do one quick example next where I give you a little more detail. But if I want to find the percent composition of lead, and I want to find the percent composition of oxygen, I'm simply going to divide both of these by the total molar mass. So total molar mass is 239.2. So lead is contributing to 207.2. I divide that by the total. And oxygen is contributing 32 grams from the 2 oxygen atoms. And when we then make sure to multiply by 100 each of these, I'm not showing that, but you multiply by 100 and you'll end up with your percent composition. So this is based on mass, and it makes sense that the lead is contributing a much larger component overall for the mass. And one other thing, if you were to add these together, in this case, there's only 2 of them, but depending on how many you have, it should total up to right around 100%. Based on rounding, it might be slightly off, but it should be really, really close to 100. So that's an easy way to always check if you did your percent composition correct or not. So let's look at an example real quick here, a little bit more involved. So we're going to look at zinc acetate. This is actually the compound in those reusable hand warmers. If you ever used those before and you've seen that chemical reaction, this is what's involved. And I did purposely choose a little bit of a goofy polyatomic ion here in the parentheses just to practice counting atoms, because we have to find molar mass first. So remember, with molar mass, we want to take each of the elements present. And in this case, there's 4 of them. And we want to make sure we know the contribution of each of these elements in terms of its mass. So to find the molar mass for zinc, there's only 1 atom of zinc within this compound. When you look at your periodic table with some rounding, the molar mass is 65.4 grams per mole. And so zinc is going to contribute 65.4 grams. Carbon, be careful. This 2 applies and distributes to everything within the parentheses. So there's actually 2 plus 2. So there are 4 carbon total. When we look at our periodic table, each carbon is going to contribute 12 grams. And so total contribution from carbon for the mass would be 48 grams. We're simply multiplying these 2 together. Hydrogen, again, this 2 is going to distribute to the 3 hydrogens, so you actually have 6. So 3 times 2 gets you 6. Each hydrogen with rounding is 1.0 grams, or probably 1.01 for your rounding. And then 6 times the 1 means that hydrogen is contributing 6 grams. And then finally, oxygen. Again, this 2 distributes to both oxygens. So there's 2 plus 2 for a total of 4. And with rounding, each oxygen is going to contribute 16 grams, 4 times your 16, and you get the contribution due to oxygen. And now what we can do is total all of these up. And this gives you your total molar mass. So again, what we've been doing up until right now is just finding the molar mass, but to do percent composition, I need to plug into that equation 4 times. So individually for zinc, it's contributing 65.4, but to find what percent that is, I'm going to divide by this total molar mass and then multiply by 100. And we'll do that for each of these elements. So once we divide each of those contributions from each element and multiply by 100, you'll get your molar masses. I'm sorry, you'll get your percent and the percent composition, do the mass. And so if you're to total these up, they should end up really, really close to 100%. If it's off just slightly because of rounding, that is fine. But again, it's an easy way to check your work. Just real quick, as we work through this, there's actually a number of real world applications to these, and we won't get into them. Something like this would be like an AP chemistry thing that you would explore. But sometimes in movies or TV shows, like especially crime shows, you find this unknown compound and they send it through this machine. And sometimes they'll show you these graphs, coming out of the machine, and all of a sudden they can figure out what the composition is of that compound and what it is. And this is actually what we're doing, kind of with the percent composition connection here. All right, so finally, if you would like one more practice problem, here it is. The worksheet, the online worksheet that you'll do with this is a little bit challenging. It's not quite as simple as just find these molar masses and then find the percent compositions. So it's going to challenge you a little bit. So if you'd like one more practice, just to make sure you're feeling okay, you can pause and work on this problem. But when you correctly identify the percent composition for phosphoric acid, it should result in these percents, again, with a little bit of difference potentially because of rounding and molar masses. So that's it for this set of notes. If you are interested in getting some help, I'm probably hanging out in the classroom right now, waiting for anyone to get in the chat and get help. So if you want some help on percent composition, or as you work through the worksheet, please let me know. Otherwise, I need to run upstairs and grab some ties for the week. I will see you all in class.